Welcome to today's session of STEP in Engineering. Topic for today's session is Fundamentals of QRA Study. Our trainer for QRA Study is Ms. Pia Judith. She is working as a lead process safety engineer. She has 15 plus years of experience in fire and gas mapping study, QRA, hazard study, emergency response, disaster management. We heartily welcome you for the session, ma'am. Thank you for joining us today. I request Pia ma'am to take this forward.
What is QRA study and what is the methodology? So methodology involves 5 to 6 major steps. So each and every step we will study like hazard identification, consequence analysis, frequency analysis, risk analysis, alarm and risk acceptance criteria. This is acceptance criteria as like your exam mark criteria, like eligible mark is 50, right? Similar way, whether your risk is acceptable or not, we have some criteria. So that also we will say. We will study and what is risk assessment on an overall and what is a lab demonstration and applications of QRA where we apply this quantitative risk assessment study and what are all the softwares used and what are all the documents required for carrying out the study and what are all the useful references that you have to go through before carrying out the study. All these things we will see into this presentation. Okay. So what is a quantitative risk assessment study? As like each and every study, as like hazard study, as like SIL study, or as like hazard study or as like any other technical safety studies, this study is also a very good and systematic approach to identify the risk. On an overall, we are going to identify the risk and we are going to assess the risk, whether the risk is acceptable or not. Okay, but in order to identify the risk, what is the key major thing which we required? The first and basic thing which we required is hazard. Okay, so if you know the hazard, then only you can identify the risk. So the way what I am saying itself, hazard and risk, it itself, the way I am saying itself, you may able to understand both the terminologies are different. So what is hazard? So if you are cooking, okay, if you are cooking in the kitchen, okay, so and if you are touching like a hot vessel, so whether it is a risk or hazard. So we can say it is a hazard as well as it is like touching the hot vessel, the touching that probability. So on an overall it will gives risk. So but it has both the things, both the terminologies, but what is hazard and what is risk, you need to identify, or otherwise you need to understand it very clearly. So which sequence of action is called hazard and which sequence of action is called risk. Okay, so that I think you may understand it very clearly. So when you go through what is consequence and when you go through what is risk and all the other things. Okay. So let me move. So on an overall, once again, I'm saying quantitative risk assessment is a systematic approach to identify hazard, to identify risk or otherwise to calculate risk and to check whether the risk is acceptable or not according to the criteria. Then we will be giving, if the risk is not acceptable, we will be giving the mitigation measures or otherwise safeguards in order to minimize the risk. The entire process is called as quantitative risk assessment study. Okay, so while discussing about the quantitative risk assessment study, the two major terminologies what you want to like very thoroughly understand is to get the difference between the what is hazard and what is risk. Okay, so let me go into the detailed methodology of this quantitative risk assessment study. So what is quantitative risk assessment study? So I'm going to think about, or otherwise I'm going to explain about the quantitative risk assessment study with respect to the process industries. Okay, so because this particular quantitative risk assessment study is applicable for many kind of industries, though it is only like predominantly uses only with respect to the process industries, because risk means risk will be like evaluated only for the people or for the environment or for the asset or for some suitable flora and fauna conditions and all those things. In that perspective, so process industry only will be operating in this perspective, which will be like polluting, which will be like soil pollution, creating soil pollution or otherwise environmental pollution, whatever it is, and which will be like may create an impact to the asset. Asset means the company vessels and all the other things. Okay, as well as which may give an expose. Whoever is the people who is getting exposed to that particular condition, they may also get affected. So with that perspective, with the process industry perspective, I'm going to define about this quantitative risk assessment study, and based on that only the methodology also described over here. Okay, so we need to first, and even for whatever may be the study, we need to understand what is the scope of the study. So for which facility we are going to carry out this particular quantitative risk assessment study, and what is the purpose we are going to calculate the quantitative risk assessment study, that is has to be clearly understandable. Okay, then only we can implement accordingly some suitable kind of methodology and criteria, and accordingly we can assess. So the first and foremost step is to understand the scope and understand the objective. Once the scope and objective is understood, then we have to identify what are all the hazards. There are n number of procedures are there to identify the hazards. Okay, similar way of similar way, QRA study will also have latest standards. QRA standards are referring to identify hazards in a suitable way. So we will be identify the hazards. So once after identifying all the hazards, then we need to assess or otherwise evaluate what is the consequence which is coming out of that particular hazard. Okay, so I have given a very vague example. Okay, very vague or otherwise a very simple example, touching a hot part. Okay, in a kitchen, correct? So I haven't defined very clearly what is hazard. I haven't defined very clearly what is consequence. I haven't defined very clearly what is risk, because I'm going to get the answer from this after this study, after the presentation. Okay, so answer from you only. Okay, so consequence, evaluate the consequences. So what are all the consequences in QRA perspective? We are going to define the consequences with respect to the process industries as toxic. Okay, then if any kind of fire accidents, so fire, and then if any explosion, so explosion. So only these three consequences we are going to define as QRA study. We are going to define in the QRA study with respect to the process industries. Okay, so all the other consequences we won't quantify, we won't consider at all for the QRA calculation. You got my point. So with respect to the process industries, there are so many hazards. So we'll be evaluating the hazard. For evaluating the hazards, there are a number of procedures are there. Okay, so that procedures anyway you will be understanding it thoroughly when you are pursuing the study or rather when you are performing the study. Okay, so with respect to the consequences, so only we are going to limit the consequences into three categories. One is like fire consequence, one is like a toxic consequence, and third one is like explosion consequences. So only these three consequences we are going to consider for the QRA study with respect to the process industry is concerned. Okay, then we are moving on to the failure frequencies. So what is failure frequencies? So we are saying that a hazard is there, a consequence is there. So what are all the failure frequencies? So if a particular hazard can, so how long or otherwise when the particular hazard may happen? Per year or otherwise per month or otherwise per day or otherwise per hour? So how long or when? Okay, so in order to answer this how long and when, so numerical value. Okay, we are giving the failure frequency. So for example, if I say breaking off or otherwise a failure of the like a cooker gasket may happens every 6 months in your kitchen vessel only I'm talking about. Okay, so if you're cooking something in, if you're cooking something in the like a kitchen, okay, using a gas cooker, okay, and if you're touching the like a gas cooker, it is hazardous. It is one of the like a hazardous event, as well as what is the consequence, fire consequence and all those things, correct? So how long your gasket may get failure in order to the gasket releases or rupture of the cooker or something like that, maybe once in 6 months. So that once in 6 months is called as the failure frequency. Okay, so we need to identify how long the hazard can happen, how often can the hazard can happen. Okay, not how long, how often that hazard can happen. So that is what is called as failure frequency. Once you know the consequence, once you know the failure frequency, we can easily evaluate the risk. So what is the risk? As a risk in terminology is called as consequence into failure frequency. So we are going to identify the consequence in terms of numerical value. We are going to identify the failure frequency in terms of numerical value. And I have said that risk is a product of consequence into failure frequency. So once you get this two numerical value, when you multiply it, you can get the risk value in terms of numerical value. So that's how you are estimating the risk. So, but the risk, whether this risk terminology is applicable for all, no. As I said, the risk terminology is applicable for the asset or otherwise for the environment or otherwise for the people. So, what way we can express the risk in terms of people. I'm not going to talk about the environment as well as asset and other things. So that we'll be carrying out when we will be coming to know about it when we are going to perform about the study, or otherwise when you yourself is doing the study, or otherwise through some other means. Okay. So QRA study focus only about the people's risk mainly. Okay. So how we can express the risk. So that also we are going to see in the coming slides. Okay. Then once after identifying the numerical value of the risk, we are going to evaluate the risk, whether the risk is acceptable or not according to the guidelines and criteria. Country to country, company to company, they will be having a different assessment criteria. So according to the assessment criteria, whether that the risk is acceptable or not, that we are going to evaluate. If we are going to categorize the risk in terms of acceptable level, then we will say, okay, follow your safeguards. Okay, some kind of generic safeguards we can give. If your risk is in alarp level or something like that, what is alarp? I will explain in the later slides. So then we will give some mitigation, okay, to bring down the risk. Unacceptable level also, either you have to drop the project or otherwise you can give some suitable mitigation measures in order to bring down the risk to alarp acceptable. So this entire process is called as risk assessment. So once you are going to present the risk in terms of numerical value, which is a quantified way, so this entire process is called as quantitative risk assessment. QRA doesn't stand as quantitative risk analysis or qualitative risk analysis or qualitative risk assessment. QRA is a quantitative risk assessment. Correct. I have used risk associated with risk two terminologies, associated with QRA two terminologies. Okay, so leave about the other three probabilities. The one and only probability with this two combination is quantitative risk assessment. So quantitative risk assessment means it is QRA. Clear? So and it is a typically applicable for process oriented technical safety studies. Okay, process oriented means even it can be applied to some kind of software industries and some kind of miscellaneous industries, but majority in predominantly or otherwise how often we will be using this particular study to assess the risk associated with the process industries. Not process industries, I am saying, not only oil and gas. Okay, clear? So if you give a risk control measures and you are actually evaluating the entire process, okay, this kind of study is called as risk management. So until the estimation of the risk, it is called risk analysis. Once you are assessing using the criteria, then that is called as risk assessment. And if you are giving some suitable recommendation to minimize the risk and you are following up the particular project or otherwise particular facility QRA study, that entire process is called as risk management. Is it clear? So let me go with consequence. I have defined a terminology called consequence. So what are all the consequences? As I told you very earlier itself, only the three consequences which is limited with. So one is fire consequence, second one is like a toxic consequence, and third one is like explosion consequences. With respect to the process industry is concerned, still more we are categorizing the fire into different types of fire. So what are all the fires which we analyze using the QRA study is like one is pool fire, second one is jet fire, third one is flash fire, and next is like explosion. There are different types of explosions are there, overpressure explosions. So one is like vapor cloud explosion, another one is like boiling liquid expanding vapor explosion. Okay, this is applicable for LPG and other kind of materials. Okay, so and these are all the things, key major things which we analyze with respect to the consequences, which we analyze with respect to the explosion. And the last one is like toxic gases and toxic liquids. For example, release of H2S, release of ammonia, release of chlorine, and all those things. Okay. So which may give you a particular consequences like toxic hazards. So once we define all these consequences, okay. So what are all the effect of these consequences? Why we are identifying the consequences? Consequences means hazard is there. So out of which some consequences coming. So out of the consequences, even if I am touching a small hot vessel, okay, like for example, if I say 33 degrees Celsius hot vessel, so it won't give you much impact, right? 32 because room temperature is around 31 to 32. So if you touch as a very simple, even though it is still a hotter vessel, but if you're touching the 33 degrees Celsius or 32 degrees Celsius hot vessel, it won't give you much consequences, right? Your skin won't burn. Correct. So a certain degree of radiation only will give you effect to your skin, body or something like that. Correct. So what are all the heat radiation which may affect? So that particular heat radiation, and according to that particular heat radiation, we will be assessing the damage. Correct. So damage caused by heat radiation on a material or a people. You got my point? So for assessing the heat radiations, we will be defining what kind of heat radiation. So whether 4 kilowatt per meter square radiation or otherwise 12.5 or otherwise 37.5, what kind of radiation will give you what kind of impact. Okay, that's what we will be finding in the consequence analysis. Okay, so similarly, explosion. So what kind of overpressure bar will give you what kind of impact? So what are all the overpressure bar I have to study for this particular project, or otherwise I have to define for this particular project to identify or to analyze the consequence results. Okay, then what impact it will possess to a particular structure or otherwise people. Structure means in order to assess the asset risk. So structures are identified. Then similarly, damage caused by toxic exposure. So what kind of toxic concentration if you inhale or otherwise if you expose to, you will be like affected. So what are all the toxic exposure concentration I have to analyze for the study. So all these radiation level, explosion level, toxic level, as like assessing the risk criteria for assessing or for analyzing the consequences, you have to define for a particular project also. You got my point? So it is again a defined criteria. So for the defined criteria, you have to evaluate the consequences. So effect of radiation, what are all the effect of radiations which I have told you? It is described over here like 1.6. So what is the effect? 4.7, what is the effect? 6.3, what is the effect? 12.5, what is the effect? 25, 37.5, and so many other effects was that. So depends upon the project to project, depends upon the effect. Okay, description. So you will be defining for a particular project and you will be analyzing that particular kind of radiation, whether it is there or not, whether that particular kind of radiation is arising out of that particular hazard or not. If it is arising, how much distance it will impact. All those things we will be studying with respect to effect of radiation, with respect of overpressure also, like 1.7 bar, 0.01 bar to 1.7 bar. We will be what will be the effect. So whether that much kind of overpressure level is arising or not. If it is arising, how much distance it will go. Okay, all these things we will be studying. Similarly, for the toxic dispersion also we will be studying. Okay, like how much concentration. So what are all the levels of toxic criteria which is given in the guidelines is there are n number of levels are given to assess, like because ppm, like if you are exposed to a kind of a smaller ppm, according to the smaller ppm you will be like smaller ppm concentration, accordingly to the smaller ppm concentration you will have some effect. So the higher the concentration, the adverse the effect. So guidelines as well as some safety norms has described like OSHA, CC, there are n number of standards are there, guidelines are there, which they have defined a particular concentration as like a TLV, some concentration as like a STEL, so some concentration as a ERPG, some concentration as TEL, so LD50, LC50, all this abbreviation you will be studying in like if you perform this particular QRA study or if you go through some other kind of technical safety studies, you will come to know, because I'm not going to describe in detail what is like a threshold limit value and what is like short term exposure limit value and all those things, and all immediately dangerous to life and health, IDLH value, and lots of n number of studies are there. So like n number of toxic concentration levels are there for different to different chemicals. So what kind of like these kinds of limits you are going to define for this particular project, again as like radiation level, as like overpressure level, you are going to define. And for that particular explosion limit level, what will be the distance you are going to analyze with respect to the consequences concerned. Okay, so now we are moving on to the like frequency analysis. So the two major step I have described, one is like hazard identification. Hazard identification I just gave as a hint. Okay, so then detail it. I have described a little bit in detail about the consequence analysis. So now we are moving on to the risk failure frequency analysis. So failure frequency analysis means how often, correct? So if a failure happens at a particular kind of process industries, so you may not having the data. Okay, we may not having the data, or otherwise even the company may not having the data. So some kind of organizations are available, they are following the data. If for example, if a plant with a pipeline as well as equipments are there, pump and other kind of equipments, okay, so how often a particular pipeline gets failed, okay, carrying a particular kind of material, how often a particular kind of pipeline gets failed. Pipeline failure means a leak or rupture of a particular pipeline. Okay, so how often an equipment vessel can fail, equipment or vessel can fail, or otherwise the fittings with respect to the equipments can fail. So all these data will be like we are like fully dependent on the databases. So the databases was provided by some of the organizations like TNO, OGP, EGIG, and ORADA. Okay, from those databases, we will be like calculating the failure frequencies. So that will be presented in the database as a numerical number only with respect to the failure cases. Okay, so those databases will be like fully dependent on for the failure frequencies. Okay, from there we will calculate the failure frequency and we will feed this failure frequency as an input to the modeling softwares. Or if you are doing a theoretical, if you are performing a theoretical calculation of QRA study, then we will directly incorporate those values and we will multiply with the consequence values what we are evaluating, and we will be finding the risk. So in the next part is risk calculation. So as I told you earlier, risk is a product of failure frequency into consequence. So consequence will be like the unit for the consequence in general is like death per particular event, fatality for a particular event. Event means there are lots of like accidents, incidents, which is happening in a particular process industries or oil and gas industries. All those accidents and incidents which may related to a loss of containment scenario. Okay, because loss of containment. So once the loss of containment, once a material is released to the atmosphere only, you will be like exposed to a fire, you will be exposed to a toxic, you will be exposed to a overpressure explosion, correct? So whenever a material is released to the atmosphere, if you get a fire source, then a material will get catch fire, correct? So if a fire catches, if any people dies, then how many people dies? So if a fire catches, what is the cause for the fire catches? What is the cause for the release of the fire, or otherwise the source of the fire? Okay, so which means that a pipeline leak scenario or otherwise a pipeline rupture scenario. So in that way we are like quantifying the consequences. So and we are just taking the frequency value from the databases, we are just multiplying. Theoretically you can perform the study also, but it is a time taking process. So we will be using the software to perform this study. So then we will be like quantifying the risk. So as a result of risk analysis, like we will be having a risk in terms of numerical value. So as I told you before, quantitative risk assessment means the risk terminology associated with the quantitative risk assessment defines only the risk associated with the people, not with the asset or not with the environment. Okay, environment means it is environmental risk assessment or otherwise environmental impact assessment study, and with respect to the asset means we will say it is a fire and explosion risk assessment. Okay, so QRA means it is like a risk associated with the people. So what are all the risks associated with this particular people? So how can we express the risk in terms of like associated with the people? For example, if a group of people is there, okay, if a fire accident happens, okay, if for example you would say if a tanker is passing on a road, Or otherwise, if a tanker is standing in the petrol bunker, suddenly the tanker catches a fire. Whoever is standing near the tanker will be exposed to the fire radiation, or otherwise they may catch the fire also. Okay, depends upon the material which the tanker catches. Okay, so depends upon the failure rate or release rate from the particular tanker is exposed. Okay, so whether it will affect a single people or otherwise it affects a group of people. So individual risk means for a particular period of time, okay, defined as the frequency at which an individual may expose to a particular hazard, okay, or a harm or a consequence. Got it? Only one individual. So presenting risk for an individual person is called as individual risk. Okay. So if you are presenting a risk for a group of people, then it is called a societal risk. The terminology defined itself. Societal means society, group of people, correct? And individual means individual. So the terminology itself is describing the same way. So if you are going to present a risk for the group of people, then it is called as societal risk. If you are going to present risk for an individual, then it is called as individual risk. Is it clear? So now I am going to. So how to express the individual risk in terms of QRA perspective? So we can like present the like individual risk in terms of like multi-level individual contours. Contours means risk value. Risk value consequence into like a frequency value will be presented in terms of like this green color line is there, no? This green color like curve kind of thing is there, no? So that much area if something happens at inside this red color area, okay, so how much impact will be there, how much distance this particular kind of risk will be there, okay, in what order the risk is. So nearer area the risk is very high, which is like e raised power minus 6, and the farther area it is e raised power minus 7, and but still the risk is going still the green color till the green color area, which is e raised power minus 8. So we are going to present individual risk in terms of like a contour, which is called as multi-level individual risk contour. Multi-level means each and every level, how much will be the risk in terms of order, in terms of order. Okay. So what is the unit for risk? Consequence into failure frequency. Unit for the risk will falls in the unit for risk also will falls under any guess? Failure frequency event per year into that per event, some numerical value per year. Okay, the unit of the risk is some numerical value per year. Okay, then we are presenting the societal risk. How we are going to present the societal risk? So we will be presenting the societal risk in terms of FN curve. Like okay, frequency into like fatality for n number of duration. How much duration? Okay, so that is what is called as FN curve. So like a kind of like a X and Y plot, we'll be presenting the societal risk. Again, this unit for this particular risk also, it's like some numerical value, like 1 into exponential term, some per year. Okay. So I told you some kind of criteria for evaluation. So there are n number of criteria is available, but predominantly used criteria is HSE UK criteria. HSE is health, safety, and like environment and all those aspects of like one kind of organization. It is like it's a London-based organization. They are defining some criteria for the assessing the risk associated with people. Okay, so what all the criteria is like one is like acceptance criteria, which is like this is like a acceptable level criteria. So when the risk is falling under the level or otherwise equal to the level of 1 into 10 raised per minus 6. So those kind of criteria is called as like acceptable criteria. If the risk is falling in between e raised per minus 6 or otherwise 1 into 10 per minus 6 to 1 into 10 per minus 4, if it is a on-site plant, if it is a plant, then the like for the people who is working in the plant, the criteria is 1 into 10 power minus 3, and for the people who is staying adjacent to the plant, so if any residential population who is staying adjacent to the plant, for the public it is 1 into 10 power minus 4. Okay, so these are all. If the risk is like falling in between these two, 1 into 10 power minus 6 and 1 into 10 power minus 4, that particular criteria is called as alarm, as low as reasonably practicable. Okay, so which means that that risk is not acceptable, but if you provide some reduction measures, maybe the risk will fall down. Okay, so if you're going to deploy, or otherwise if you're going to commission a project, then apply those safeguards. So in order to bring down the risk. So that kind of criteria is called tolerable if alarp. Okay, if you produce the safeguards, then this risk is intolerable level. Okay, if the risk falls above this e raised power minus 4 and e raised power minus 3, then those risks are categorized as intolerable risk. Okay, in 99 percentage, you have to drop this case. If you couldn't drop this case, if you couldn't drop this project, then you have to think about implementation of more kind of safeguards. This is with respect to the individual risk acceptance criteria, which means that for assessing the individual risk, if you want to assess the like societal risk, this is the acceptance criteria. So what is the acceptance criteria? This kind of plot will be coming. Okay, as a result of societal risk assessment, this kind of x and y plot will be coming. So if your risk falls, this is actually generally I'm going to deploy this kind of use this particular kind of graph for the project. So I'm going to show this project. But actually, HSUK will say the risk acceptance criteria with respect to the societal risk in terms of like a scale in the order of like uh, 1 into 1 by 100, like that. Okay, you can draw the criteria wherever you want. So which means that e raised power minus 2. So the risk which falls below this e raised power minus 2, all will be categorized as like acceptable risk only, and the risk which is categorized above this e raised power minus 2 will be intolerable risk. Okay, but with respect to this alarm criteria, very rarely, very like vaguely HSUK will be defining, but this is like universally acceptable criteria will be following, like e raised per minus 4 with respect to the 100 fatality. If you want to define this curve for e raised per minus 4 with respect to the 1000 fatality or 10,000 fatality also, you can draw. Okay, so with respect, because how many people will be dying due to an incident? Okay, because that is described in with respect to slope. You know, na, if an x and y plot is there, if it is a slanting line is there, we will be calculating what is slope, right? So if the slope is equal to 1, so accordingly your x parameter should be there and y parameter should be there. Societal risk is defined with respect to slope 1 only, with respect to e raised per minus 2 and with respect to e raised per minus 4. But the slope line can be like ended either in 100 fatality, it can be ended in 1000 fatality, or it can be ended in 10,000 fatality. That is up to you. Clear? But in general, I will go to for a 100 fatality instead of 1000 or 10,000. Okay. Anyway, what I'm explaining, you will come to know when you are like go performing the study. The last thing is like risk assessment. So, like whatever the risk you have evaluated and kept with respect to individual risk analysis, individual risk and societal risk. Once you are assessing with this criteria, whatever I have shown here, so that is what is risk assessment. The result of the risk assessment, either you will be categorizing the individual risk in terms of acceptable, alarp, and unacceptable, or otherwise societal risk in the same way. Okay, if your risk falls in the acceptable levels, you can leave about it. So you can proceed with the same safeguards what you are following. If your risk is not following in the like acceptable level, then you have to think for the suitable safeguards. So in general, in our company, we'll be using like DNV fast and Safety software. Okay, version is mentioned wrongly because this PPT was prepared long back. Okay, and we'll be using shell company software, Fred and Shepherd also, and there are a number of CFD software is also available. Okay, so for doing the study, but predominantly for Indian studies as well as some of the Gulf studies, we'll be using this DNV fast software, because that is the, I think that is the first software which was developed after Aloha. Aloha is a user-friendly software. You can download from Google also. You can try learning quantitative risk assessment using Aloha. There is one software, ALOHA. Okay, it's a like easily downloadable software. You can calculate risk using Aloha also. Okay, and what are all the documents with respect to the process industry. The list of the documents required is provided over here. I think at this point of time, this slide is not required. And if you have some time, please copy this slide, or otherwise get this PPT from Pavitra, so that you can copy this particular slide. Okay, and you can read this documents, whatever which is mentioned over here, like AHCH CCPS documents. We will say it as CCPS. If you type CCPS in Google, this document will be like freely downloadable document is coming, will be coming in Google. You can download this document and you can read this document, which will give you a better perspective about the quantitative risk analysis as well as assessment. Another document is a TNO Purple Book guideline documents. TNO Purple Book has TNO guidelines is having n number of books, like colored books. We'll call it as colored books. So all the colored books will be related to quantitative risk assessment study, and purple book will give you the proper guidelines about the quantitative risk assessment study. Whereas yellow book will give you the detailed calculation of the consequence analysis. If you want to numerically perform the consequence analysis theoretically, then you can refer the yellow book. So similarly, green book is also available, and other books are available. So if you want to, that those books are also downloadable, so you can freely download this book. When time is like permitting, you read all those books, you will get a better idea about what is quantitative risk assessment study. Another one is like HSE UK guidelines, which I have showed you the risk criteria, right? So for which that particular thing is there, and OECD guiding principle of chemical accident prevention, preparedness and response. Before coming into the technical safety study, you should understand what is safety. You should understand what is accident. So there are n number of books. So the n number of incidents and case studies. Why such a kind of studies, or ever? If you go for the history of like a QRA study, if you want to go for the history of hazard study, if you want to know about the history of safety studies, you should know about the history of particular some kind of safety incidents or accidents. So once you understand such a kind of accidents or incidents, then only you can able to understand what this kind of technical safety studies and all. Okay, so n number of accident investigation reports and books based on accident investigations are also available. So such a kind of book is like OECD guiding principles for chemical accident prevention, preparedness and response. Okay, so you can refer this book also, which will give you a thorough idea about safety studies, not only QRA, safety studies. Okay, then loss prevention in the process industries, which is I prefer, I will ask you to read this book, though you feel very like kind of vague feeling while reading this book, but this book will give you lots and lots of information about technical safety studies. Okay, so thank